welcome. I'm Tom Vaughan, VP of Strategy from Beamr, and this is Nikki Conley.
Hi, Nikki Conley. I'm a cloud solution architect from Microsoft in our One Commercial Partner Group. And I'll turn it back over to you to get started.
So we're here to discuss modular cloud video workflows, the topic that everyone's wondering about. How do I build modular cloud video workflows? Good question. So a little intro, a little history. How did we get here? Of course, 20 years ago, if you wanted to get some video, you had a cable, a satellite, over-the-air service that you could watch some live linear broadcast. Or you went to the Blockbuster or to the store and you bought some tapes or DVDs or Blu-ray discs, and you had a home video collection maybe. That was your on-demand stuff. And the production of those formats was relatively straightforward, and certainly it worked. But today, everyone is moving to all IP video delivery for good reasons. And that requires a modern IP video service architecture. That was sort of defined by the early web streaming companies, YouTube, Netflix, et cetera. Well, Netflix was not the earliest, but initially they had sort of progressive download-based systems, but over time got much more sophisticated. That's all software-based, running on x86 compute, and the distribution network is web servers, right, that serve up the streaming video and a manifest, and they're assisted by content delivery networks, basically caching servers at the edge that have a local, closer copy of that content so you can get it quickly. But it's not just this shift from kind of live linear broadcast to video on demand and over the top. There's many shifts in video happening all simultaneously, and so this adds to our challenge. We're going from that QAM-based system to IP. We're going from live linear to any video, anytime. We're going from sort of a data operations center that was based on appliances. Each appliance in the data operations center, network operations center, had a specific purpose. Here's the encoder, here's the modulator, here's quality control equipment in the 19-inch rack, to a fully software-defined workflow. Everything is software except maybe the baseband input or output. We're going from on-prem to operating in the cloud, and there's many ways to do that. But we're also changing the video. We're accessing it anywhere on any device. We're going to encoding a full ABR stack and multiple quality tiers. We're moving from SD to HD to UHD to 8K, higher color depth, wider dynamic range. Of course, everything, thankfully, is moving to progressive scan. So that actually is one simplification versus what we had to deal with in the past. So how do we transition the entire way we do video delivery and at the same time deal with all these new challenges and opportunities? Well, your video service architecture may be different than other people's. There's many possible components you could have in your whole back end, your whole workflow and infrastructure. Some are going to be common and everyone's going to need some way to get the content in. Some way to transcode it, to prepare it for delivery, and package it with a manifest and get it ready for the web server. And some delivery network to get it to the customers, and you'll have to figure out what kind of player clients are going to support your service. But there's many other systems that you may have in your business that need to integrate with that, right? It's not just a matter of the video and audio itself and the content production and delivery. We want to do analytics, we want to do quality control, we need to deal with metadata. There's a whole bunch of business systems, account management, user experience, might be social media integration. There's many, many things that will all need to work well with that video production pipeline and integrate with it and be able to leverage the data that may come out of it for your business. So that just sort of adds to the complexity. So at the end of the day, we have a fundamental question. Do I build or do I buy? Or do I do some level of both? And that's really the key question you have to answer. Certainly there are many vendors. When you come to Streaming Media East, some of those vendors are here. But if you go to the other video trade shows, NAB, IBC, you'll see all of them, right? They all have big booths. And there's, the Harmonics and the Elementals and the Azure Media Services and dozens and dozens of vendors who have fairly complete solutions on one flavor or another of transcoding frameworks that can meet all kinds of requirements and specifications. And that's one end of the spectrum. In fact, I could use a cloud service. I could just have someone take care of everything for me. I'll send all the content there. I get on a web interface. I interface with that. I talk to it through APIs. And they handle everything for me. That end of the spectrum is likely to be more expensive operationally in the long run, but very low upfront costs or friction to get started. So it may be a good place to start if you're spinning up a new service. Bigger companies who have more resources, they want to own it a bit more, right? They want to have a large development team building that service, customizing it for competitive advantage. And so they want to have their hooks in it. They want to really be able to customize it to do anything they want. And so they're going to be a little more towards the build end of the spectrum. And they have a variety of choices. The very biggest companies like Netflix, Amazon, others went so far as to hire very large engineering teams. Of course, they were early entrants, and there was very little for them in the kind of web video space to buy. So they built based on kind of component building blocks, open source libraries, FFmpeg, X264, et cetera, and build out the whole capability. And for VOD, that's a little bit easier. For live, that's certainly a bit harder. But it does require quite an investment. You have to be serious to hire hundreds and hundreds of engineers to build out everything you want and need. So there are some options in sort of in the middle for developers, for people who want to customize things. They can buy some of the core technologies and components as kind of complete libraries and modules. Beamr is a company that does make those type of solutions that are a little bit more powerful than building from the ground up. But there are a number of others, and certainly cloud vendors like Azure Media Services offer those discrete capabilities for development teams who really want to customize their capability. As a business person, this buy versus build decision is made by many, many companies in many markets and industries, right? It's a very common question to answer and to ponder. And when I went to business school, the way we were taught to think about it, which I think is correct, is your company and your business has some key sources of competitive advantage. And it's different for every company, right? You might be the low-cost provider, and I just make sure everything's cheaper than the other guy. And so there's a certain segment of the market that's always going to come to me because they're very price sensitive. You might have unique content. You might have your own content, or you have some unique reach, a unique audience you're trying to serve, and you're customizing for that particular segment. So at the end of the day, you probably want the developers, your staff that you've invested in, to focus on the things that build your competitive advantage and extend your competitive advantage. Building that service, right? Building the customer-facing pieces, the capabilities, the features, or extending your reach into places you want. You don't want them building core building blocks that someone else has already built and you can license cheaper than it would cost you and your team to build, and you can get started a lot faster. So that's probably the high-level way to think about where you want to make your investments. I'll give you an example. I am in the video codec business. I've been in that business for quite a while. And I got most heavily into it in 2013. I joined a small company. I was the person who started the X265 project and ran that for 5 years. And so we were one of the earliest companies building an HEVC H265 encoder. And at that time, we learned very quickly that about 20 plus companies around the world also decided they were going to spin up a team and they were going to build their own HEVC encoder implementation. That was a good idea, they thought. And if you think about it, it's a standards-based thing. I need to take uncompressed video as input. I need to produce this standards-compliant bit stream as output. And 20 companies are not going to produce the best encoder. In the end, probably be only one that is the best at doing that and gives you the most performance and the most compression efficiency and has all the necessary features, is the most robust. Some may specialize in, ultra-low latency or some other, subdomain, but software kind of tends to be a winner-take-all business, and you're either in it to win it or you're not really in it. And so over time, many of those companies wound down their teams, wound down the effort. After spending, in some cases, millions of dollars, having fairly large teams for a number of years working on the effort, and they realized when they, even looked at X265, the open source encoder, their own internal effort was not on par. This made no sense. They were never going to surpass it. So you certainly don't want to make that kind of mistake where, I invest and I'm going to build instead of buy, only to realize a few years later you just wasted all that money, and you could have the same engineers working on something that goes right directly to your source of competitive advantage. I'm sure there are many similar examples. So inside that media processing workflow, at the very heart of it is what we call a transcoder. That's a media processing framework that sets up a graph. And there are components inside that graph. I just grabbed this like in a Google image search. This isn't really a good example. It's probably a file-based encode of something. But there are many such media processing frameworks, a number of them that have been developed. This one, I think, was Microsoft DirectShow. And so such a framework needs to look at what job do I need to do? I need to go from here to there. And what are all the steps to go from here to there? I have to open that file, so I need a filter that knows how to open and parse that file. I need to demux the audio from video in this example. I need to then decode the audio and video. I need to then re-encode the uncompressed audio and video into the right format, multiplex them back into a file or a transport stream or something. So this is a highly simplified example of what happens inside a media processing framework. Of course, if you're sophisticated and you're running a top-tier service, you may have stereo versions of this and 5.1 channel or other multi-channel versions, many different tiers of video quality in your adaptive bitrate encoding stack, metadata flowing, quality control steps. As I said before, there are a lot of things that have to go on. So that framework needs to figure that out, set the job up, run the job, keep everything operating smoothly, make sure, of course, that the outputs from step A are compatible with the inputs of step B, and monitor that execution, allow you to dynamically change parameters in some cases on the fly as needed. There are a lot of basic tasks that this needs to do. Some commonly known media processing frameworks include, the most well-known is probably FFmpeg. There's a fork. Some of the developers got mad at the other guys and made a fork. It's called libav, but they're very similar. There's GStreamer. And then there are proprietary transcoders, like our transcoder. Beamr has built a transcoding framework. And of course, all those other vendors that you know and love in the video industry that provide this kind of capability, they have their own internal transcoders. So as I mentioned, the fundamental challenge, set up a graph, a media processing graph with the right order of operations, ensure everything is pin compatible, the outputs of one are the right format and compatible to go into the inputs of others, handle all those splits and joins, metadata, audio, video, subtitles, everything else that needs to, all the information that needs to flow. At the end of the day, keep the audio and video in sync. So they're the fundamental challenges, but there are more advanced challenges, right? I need to do quality control on the incoming video. If I'm smart, I'm going to do some quality control. Is this really video? Does it have audio? Are there other issues with it? for live transcoding, there are a set of particular challenges, right? I may be getting a feed, and that feed may drop momentarily, some because of communication issues or whatever. Am I robust enough that if some frames are dropped, do I pick right up where I left off and can I conceal that error the best I can? Can I keep moving? Or, the last thing you want in a live operation is something to just sort of crash or abort because it got some bad input. So all kind of live systems need to be extremely robust, and they don't get phased by bad input, right? You need to do duration testing, fuzz testing, all kinds of testing to make sure this thing is absolutely bulletproof. File transcoding is very common for companies. Netflix has talked about this publicly, how they chunk the video into reasonable sized chunks and then distribute that work. And that allows them to do very high quality, kind of go slow encoding, but yet the turnaround time for the whole job is much faster because they've parallelized the whole set of operations. And that's relatively straightforward in concept, but not necessarily straightforward in execution to do that, dealing with all the kinds of machines you're going to run on and so on and so forth. One-to-many ABR encoding and packaging, and you may be packaging in multiple formats or creating multiple manifests to deal with different player clients and so forth. But for us, as kind of low-level library guys at Beamr, one of the things we think about a lot is really optimizing performance. When you have all this going on, let's say I have a dual socket server, it's got 48, 60, 72 hardware threads, and I've got a one-to-many encoding job going on, and I've got a 4K, one or more 4K tiers in the ABR stack. I've got one or more 1080p tiers, multiple renditions of that audio and video. The 4K job is going to need more hardware threads than the 1080p jobs, which will need more hardware threads than the smaller jobs. I need to load balance everything. I need to keep the timing of all those operations very tightly synchronized. When I have a decoded frame in cache memory in a particular chip in a particular socket, I can do other operations. I can do scaling operations on that. I can do other operations more efficiently than if it has to move to system memory and it's out of the cache, right? So there's a lot of performance optimization that's possible if you really understand what's going on before you get going and you synchronize things really tightly. So as I mentioned, Beamr did develop a transcoder. We didn't just start yesterday. We had a transcoder framework years ago internally. We even had a semi-pro Windows product that was out there. It didn't check all the check boxes for a large telco, cable, satellite company in terms of all the formats and standards that it supported, but we realized it had all the basics, and it's a very, very nice architecture. So we started to flesh it out quite a bit more, and the key, again, is that core architecture. It's designed for modern development, so it's scalable. It can run in containers. It's very, very flexible. It can be orchestrated with Kubernetes, and it's very powerful and very fast. Whereas an open source transcoding framework like FFmpeg, it's my understanding it really kind of deals with frame passing, standard I/O, passing one frame from one filter to the next. It's not doing all that kind of global coordination and thread management and performance optimization that you would need for a very high performance live encoder. Fine for VOD, especially when you're chunking and splitting jobs and doing them each as discrete jobs, but for some of the more challenging live situations, it's not really up to the task. We realized that we are not going to compete with all the incumbents in the transcoding space that have been doing this for 20 years and check all the checkboxes. But we really built this as a means to an end. We have this core SDK. It's better than other SDKs for the core encoding functions. And in order for us to license it to many companies, they need something to plug that thing into. And not all of them have the development teams that can do that, or they may have other transcoders today that they can't plug our SDK into very easily. And they want to be building. They want to build a live capability. FFmpeg is not helping them do that. They want to solve this problem, so we realize there's sort of a gap in the market. So we are kind of reaching the stage where we're ready to make source code available to our customers, talking to partners about how to make that more widely available. We do have already a free to start program, so if you go to beamr.com, anybody could download this and have 100 hours a month for free and try this transcoder. And it is both a live and VOD transcoder. This is kind of an earlier slide, a little bit of an eye chart, but it does check off all the kind of key boxes in terms of format support, the things you would want as inputs, outputs. We partnered with Unified Streaming to do packaging, but it is very flexible in that way. And so you can run a highly scaled system, have many transcoder nodes working. We have this REST API that our core libraries talk to each other with, and we have a web interface called the Beamr Manager, strictly through HTTP, through the web, that knows the APIs for the transcoder and our other libraries and can give you that dashboard that you need to see everything that's running and set up jobs and workflows and so forth. So that kind of covers the pieces I wanted to cover. Let me hand it over to Nikki Conley.
Thank you. So very first, what I wanted to show you is the suite of products. I'm going to walk over here some so I can focus on a few things. So as we build through this, you see for each of those areas, there are things within Azure that you can use to leverage should you want to build. There's also partner solutions that can help as far as the buy in each of those. Next, we have content creation. So for all of that, there's plenty of things. There's our GPU-enabled VMs and high-performance storage with Avir. That stuff's pretty awesome. I saw it at NAB. So for content management, which this is really cool, is all the cognitive services, video indexer, the transcoding with media services, and then content distribution for your live and on-demand. And lastly is your monetization. How are you going to make money off of your content? Because that's really the goal, is making money here, right? So with this, there are some issues. You know, you've got issues with cost. You've got issues on that initial CapEx that's in there. And what I wanted you to look at here, go ahead and take in the whole slide, but right here, what we're looking at Microsoft is glass and DNA storage. So this is where you really get that high quality, high quantity storage for those large media files when you get to the 8K. This is something, so let's say you don't want to build, you want to buy. This is an example from Avid. There's several others, but they have built this on top of Azure. And it has all of these solutions that should you just need asset management or post-production. You know, post-production can be expensive if you're running on some high-performance machines for those editors. And then there's also some cloud solutions they have in there. So next we've got our content management and discovery. Horrible DR, hard to do, really, really hard to do. You've got big media files. What are you going to do with that? And then you have to archive all that. You don't want to have all of that in hot storage where you're paying a lot of money for hot access when it's rarely accessed. And so on this one, I'll let you take in this slide again. I'm not going to read through it. But one thing to look at is the improved language models, something that we're working on. So within Video Indexer and some of our speech-to-text, we've looked more into multiple languages. So typically now there's film and video content that doesn't just have English or doesn't just have Spanish or doesn't just have French, just to name a few. You're going to have multiple languages, and that's where this type of work comes in. Also, there is more for modeling, so you can create models within your content library so that maybe you have your own face library. Maybe it's people within a university that you want to identify that you're not going to find on IMDb. They're just not famous enough to be there. So if we look at this one, this is one of my favorite things. I'm a huge, huge Big Brother fan. And if anyone has seen it, they've got 50 cameras throughout the house, 20 cameras outside, and they're recording 24 hours a day for like 3 months. But they don't want to, when they're editing this, they don't want to show you someone sleeping, brushing their teeth, not talking to anyone. They want to have good content. So when people are whispering, when they're talking in a corner, when they're quietly trying to move from one room to another to have a private conversation. Endemol Shine did this by using the AI technology within Video Indexer, as well as some custom models that they had to locate these things. So there's a really interesting 1:10 a.m. where they can exactly find what they want to put into a clip that is pertinent, that they know that their viewers want to see. So next is the most important. How do you get money out of your content? It does take time. You know, if you don't have AI expertise, it's difficult to get that monetization out of that data. And here, I'm just going to skip through this because I have a video I want to show you. And this is how a company called, let me see if I can play it from here. This is how a company called Dive created, is it playing? Do I have to click next?
The button on the tablet below is like a mouse button.
Hmm?
The button on the pad, below the pad is like a mouse button.
I'm trying. Won't play my video. Do you know what to do? Sorry, this video is really worth it. I went too far. Go back. Here, let me just.
It looks like it's playing.
It's not playing. I played this yesterday, so I know it works. Sorry, everyone. Let me try and play it this way. The audio doesn't work. Okay, well, I'm going to talk through this because the audio is not working. Basically, what this company did is they took this episode of Sex and the City, and they started identifying things that were in the episode that people may want to buy. So, you know, what about that suit? Or what about Carrie Bradshaw's bracelet or ring or that shawl? And so the customers or viewers can actually sit and purchase that item that they've found the identical one. Also, how to make a Cosmopolitan. Let's say, oh, I want to make a Cosmopolitan because the girls are drinking it. So that's how to make a Cosmopolitan. And basically, this is how they are able to monetize and show how you can monetize your content based off of you can monetize what you have based on the content by making sales. It's also really good when you're doing, if you have OCR recognition. Let's say there's a, this is the best example, no spoilers, but from Game of Thrones the other night, there was a Starbucks cup in there. Just kind of passed through and people caught it. Could you imagine if they left it in there, knew about it, contacted Starbucks and had like this huge like promotion Game of Thrones thing with Starbucks because of that cup? So they really could have monetized on that, but apparently they didn't run any of their edits through any sort of AI. And then I should be able to just click.
Yeah.
Okay, so we had the discussion about build versus buy, and you can see there's tons of partners that have little pieces of this as well as the whole pieces of this. So let's say you need to do forensic watermarking. You don't want to do forensic watermarking, but you know you need it, so you're going to look for someone that has it. You could build your own, or you could buy it. And so this just shows just some of the media ecosystem where if you're building on Azure, you can go to the marketplace and you can purchase the product directly from there to add into your systems. And then lastly, and I want to leave time for questions, this is just an example of a live video architecture. You can find this on Azure Docs Architectures. But basically, you know, you have your live source, you've got your channel that you're broadcasting to, you've got, hold on, let me switch hands here. If you need ExpressRoute, if that's a networking for low latency. And what's really important here, you've got your DRM, and you're using your CDN and your sources for playback. But this is a very, very high level for a live streaming. So you could use, you know, a third-party encoder like Beamr's got, or you could use an Azure Live encoder. So you can really pick and choose. You don't have like a vendor lock-in. And I think that's it. So I think we can go to questions.
So any questions from the audience? Nagesh.
Nikki, the one that you showed the video with the AI,
Mm-hmm.
Is that really done with the eye? You know, like cosmopolitan, right? The bottles being built, like when it should recognize this as cosmopolitan drink, or I mean, there's a lot of things that happen out there. That seems like a really complex model.
Yeah, it is a very complex machine learning model. So it was built out of a company in Europe, and they used the cognitive services that come with Video Indexer, as well as they had a bunch of machine learning models, so where they would look for for words of different drinks, and they'd have a whole library of keywords that they were looking for. And then different clothing, they used image recognition. So within the thumbnails, they would do image recognition, and then they would have search to go find where that you can purchase it from. And then with different vendors for purchasing, they linked up to find places so that they could automatically buy. And I'm sorry I don't have volume for that. I can show it to people if you want to see it later.
Any other questions? Yeah.
How does the I didn't see content aware in the building mentioned anywhere.
So, yeah, he asked. He didn't see content-aware encoding. Certainly, you know, the basic transcoder idea that we discussed. You can make it more sophisticated with many things. Content-aware encoding. Of course, there were talks earlier. Jan Ozer hosted a nice session on that. There are many techniques you can use. Do some sort of analysis as a first pass. Based on the results of that analysis, customize the encoding to adapt to the particular content. We're an encoder vendor. We can go beyond many of the techniques that other people use. So because we make the codec itself, we can actually see what's going on with the video and what's going on inside the encoder as it runs, and the encoder library itself can have content adaptive capability. We have a whole set of patented technology we call CABR. That is, we were really one of the first to use the term content adaptive encoding. So yeah, there's many levels you can go to. You can kind of do some basic things like use CapVBR, or do an analysis pass and do some kind of iterative or brute force, however you want to call it, testing to find the optimal resolution of those lower bitrate tiers, those renditions in the middle. Usually you're not going to scale the top rendition, that's going to be full resolution. So that's kind of the first question that Netflix published a paper on and got a lot of people going with content adaptive encoding. The first question they wanted to answer was, how do I find that optimal resolution for those mid tiers? And so it's a fairly straightforward problem. The trick is to not do 100 encodes and then do a very compute-intensive brute force analysis in order to find the answer, but to do something a little quicker, faster, and more sophisticated. And then there are other vendors that offer their solutions, but I would say one thing to think about is the core SDK itself, the encoder SDK itself, ought to be aware of what's happening with the video as it's encoding it, and can do many things inside the codec itself, and we have much more control than just looking at things on a per title basis or even a per scene basis. We can look at every frame, and we can look at every spatial region of every frame and adapt to what we're seeing. So, test different codecs and see what kind of results you get. Look at the video. June?
So with your SDK, you mentioned computer support. Are you guys actually able to do kind of chunk parallel encoding?
Yeah, I mean it's an encoder SDK, and in fact it's public that Netflix uses our encoder SDK for HEVC, and they, so any good codec SDK you can. With something before you get to the encoding stage, you can take that input file, break it into chunks, let's say nominally 10-second chunks, it could be other sizes, make separate encoding jobs. There are some things you can do wrong there, and one thing that you don't want to have is an obvious quality step at the chunk boundaries, right? So you want more or less, especially for someone who has full bandwidth and can watch the top tier, constant quality, and you don't want there to be a noticeable change up or down in quality at those chunk boundaries. Early efforts to do what's also known as split and stitch encoding weren't always perfect, and that could be one danger there. Ideally, it might be good as well to have those chunks start and stop at scene changes, especially if they're a jump cut, from one scene to the next. And then if you're using something like VBV to cap the bit rate, how do you have VBV conformance across chunks? So how do I take the context from one to the next to ensure VBV compliance? Because that's something that normally I do from the beginning to the end with kind of a moving window of bit rate averaging. So there are a few little nuances, but it's conceptually straightforward. Anybody can do it. Our SDK is very low-level library. It takes YUV frames in and produces elementary bit streams out, and it has every option and every control to do anything you want. Anything the open source SDKs have, we also have, and then quite a bit more, basically. Other questions? No? Well, thank you for coming. You're all ready to build your own modular video workflows in the cloud. All right.
Thank you.